Hi everyone from J4K. It's my big pleasure, my huge pleasure to be here with you guys to share something both about Java, about Cloud Native. I'm gonna also cover Kubernetes here. So let me share my screen. Your Java code Cloud Native ready, a live experience. Why live experience? Because everything I'm gonna do right now, I will do using live coding. So I don't have too much slides here. Actually, I have just 4 slides, I believe. Just for you guys to know who I am, in case you don't know me, my name is Elder Moraes. I work for Red Hat as a developer advocate. Here in this slide, I'm sharing with you the QR code for my YouTube channel. If you are interested in content like Java, microservice, containers, Kubernetes, Cloud Native stuff, you can go there and subscribe weekly content, both in Portuguese and English. I'm a Brazilian, so I share content both in Portuguese and English weekly, all right? I am also a board member at Untitled Java, one of the biggest Java user groups in the world. I've just published the 2nd edition of my book, the Jakarta EE Cookbook. If you know, if you are interested in Jakarta EE, my book maybe can help you. And my mission as a developer advocate, as a professional, is to help you, Java developer, to be successful on your projects, to help you to build and deliver awesome applications. All right? Okay, so today our cloud native application that I'm gonna develop here for you, it will use some cloud native approach. So I will use microservice approach, I will build declarative APIs, and I will use some APIs for this environment like health check and metrics. I will distribute it using containers, and I will deploy my application in an orchestrated environment, okay, using a Kubernetes cluster. Let me grab some water. All right, awesome. So here is the code time, okay? No waiting, no more. All right, guys. So what I'm gonna use today to build this application for Cloud Native is Quarkus. All right, and let me open here the code.quarkus.io. Always, every time that I want to create a new every time that I want to create a new project, to start a new project from scratch, I like to get here to this page, to code.quarkus.io, to start my project, because it's very productive. It helps me a lot. All right, so I will use here a group ID Quarkus, con.eldermoraes, and I will, as I'm talking, I will build a microservice. So I will build 2 applications, 2 very small applications, and one will communicate to each other, right? So the first application will be time. Here, if you never came to this website, here we can choose a lot of extensions for Quarkus, all right? I won't cover every single today, of course, but I'm gonna use some of them in a second. But for starting, I will start my application plain, okay? So plain, it will have CDI, it will have JOXRS, it will have some features based, and most of the APIs that I'm gonna use today will be from MicroProfile, all right? And the implementation of MicroProfile used on Quarkus is Moraes, okay? Moraes is the Red Hat implementation. Good, let's create this first application, and I'm gonna save it where it will be right here on live folder. And I will create the second application right away, gateway. and I will also download it here. Good, awesome. So let's just erase this guy and let me go to the terminal. So here, let me check. Okay, you are here. Unzip time, unzip gateway, and remove all right. Good. So let me open the Visual Studio Code. I like to use Visual Studio Code because first it's very lightweight when we are using live streaming and recording stuff here. Our machine demands a lot of resources, so Visual Studio Code is very lightweight for that, and also because we can use the two plugins for Visual Studio Code using Java. We have the Java plugin that is also developed by Red Hat, and we have the Quarkus plugin, also both of them developed by Red Hat. All right, so let's open our first project here, the time project. I will delete the test folder. Don't do that at home, or do that at home as we are isolated right now. But you know what I mean. Don't delete the test from your projects. I'm doing that just for the sake of time and just because we are in a demo here. So this is my first microservice. It will have the time endpoint, and it will return, guess what, a time. So local date time now, and I will use this. All right, so maybe our really small, really micro service, it's ready. What I'm gonna use right now, if you never used Quarkus, I will use the Quarkus plugin for Maven to activate what we call a developer mode or dev mode. What it will do, it's vn clean compile Quarkus dev. What it will do right now is to compile my application and start my application, and once it is done, it will make my application available for receiving requests and so on. And every time that I make some update on my code, that I change something, even when I create some new code on my project, it will reflect on my application that is running almost instantaneously. Okay, so right now it is downloading the last version of Quarkus, because the last time that I ran on my machine, I wasn't running the very last version. And this is something really interesting about Quarkus, because it is evolving very, very fast. All right, so every single time that you try, maybe you will get a new version. All right, so hello here. All right, and our application took 1 second and 173 milliseconds. All right, of course, it's not taking in count here the time that you download, but what I would like to highlight here is that application, of course, is simple. It's a small application, but even then, it took a very short time to update, to upload, to bootstrap. If sometimes you use some application server using Java, you know that it will take a lot of more time just to get the server up and running, and but some more time to have the application available. And this application is ready to be called. So here we can use a curl localhost 8080 time. right? So this is application, and if we go to the browser, we got the same result, right? So our first application here is the time application. It's kind of ready to go. Right now, I will go to the other application, our gateway application, that will access this application in order to get this time, and there I will put some other stuff related to what we are covering here today. So first let me close here and open this guy here. Also delete the tests. Remember, don't do that. Good. So here we have this one, and here it will be the gateway. Oops. All right, so I will call that other application. By that, I needed to have here in this application a new extension, not a new extension, but I will need to add an extension to this project, and it will be a REST client. So I will use here, but as I'm using the Quarkus plugin for VS Code, I have here this add extensions and just client, REST client, here, REST client. All right, so it will add the REST client to my project. Okay, it's done. So let's build our REST client. So we'll use here time service.java. All right, and this will be an interface, and I will create here a method, get time, and this will have a HTTP method, a get, and it will produce a media type, text plain, and this will have a scope of application scope, right? So here we have our interface for our client, and most important here, we need to register this REST client. So register REST client, and URI is HTTP localhost 8080 time. Pay attention because this will change in a bit. All right. You know, we are running our application, this application here, our time application. I will let this guy running just to show you that it is really running. Localhost 8080 time sleep.3 done. So printing our time here. And this application is running on port 8080. So if I try to run this other application, the gateway application, it will use the same port by default. So we need to change it. And this is other stuff that we are gonna change back in a bit, right? So here we have HTTP Quarkus, HTTP port 8081. It's good. All right, so we created our REST client. So here we inject it, and we mentioned that it is a REST client, and we finally use our time service. And instead of just printing the hello here, we are gonna gateway, just to make sure that we are really on a different application, and get time, right? Awesome. So let's here split this window and also go to the cd git live gateway. Activate our dev mode, compile, Quarkus dev. This error is related to the debug port. Don't mind that right now. All right, so application took 1 second to go up and running. Now let's call it. So I'm a little in front of the window. Let me change a little bit here. Yeah, better. All right. And what I'm gonna do here, just for testing, localhost 8081 gateway. All right, so it's getting from the time service, but we now are reaching from the gateway. And let me also create here a loop while to do this curl and is sleep and done. All right, so I have 2 microservices. One very simple, just printing the time, and the other also very simple, getting the time from the first one and printing here on our screen. I'm a little in front, but you can see it's working here. Right, so I created 2 microservices. I have a kind of decorative API here. Of course, it's very simple. And what I'm gonna do right now is to add some stuff related to cloud native. So what I'm gonna do right now first is to create a health check for this application. Why is that? Because I just told you guys that we will deploy this application on a managed environment, on an orchestrated environment. And when we do that, it's very important for the whole environment to know if application, if it is in 2 conditions. First, if the application is alive, and 2, if the application is ready. They are different, okay? Because an application can be alive, but not still ready. For example, imagine if an application needs to access some database, and that database is not up and running. So maybe the application is up and running, but the database is not. So that application is not ready. All right. So the ways to check this health check are different. All right. So let's create here in our application. And for doing this, we need to add another extension. So let's open here again. And for this, we are gonna add the health check. See, you can see the small right health. This is the, as I said in the beginning, the microprofile API implemented by Red Hat, and the name of our implementation is small right. Good, so here we are adding the health check, done. And for creating the health check for our application here, we need to implement 2 probes, what we call probes, all right? If I go to the browser here, they are the endpoint for health check, it is even already available, okay? But I didn't do anything, but this endpoint is free. It's done by the implementation, okay? It's already available, but I will add some intelligence to it. So let's go here and create our probes. So first it's the Liveness Probe. The Liveness Probe, it is quite simple. It will implement the health check interface, and I will add the liveness here. And as it is an interface, I need to implement 1 method. And the liveness is very simple. I'm live or I'm not. Okay, so if you can reach this endpoint, probably the application is alive. So check response up, I'm alive. All right. Of course, you could implement some other algorithms here, some other kind of checking, but for this demo, it's just like that. But the readiness the readiness, yes, it is a little different, because as I said, the readiness means, yes, I can be live, but not necessarily I'm ready. So let's have an example here. The annotation is different, is readiness, but the interface is the same, but the way that we implement is different. What I'm gonna do here is to inject actually my REST client, because for this microservice, I'm considering that it will only be ready if the other microservice is ready as well. All right, could be a database, another service, a web page, I don't know. But for this case, I will consider ready if the other service is also available. So time service, and I will check here based on the content, right? So if get time is null, else all right, so oops. So if it is no, I will return a health check response down. I'm not ready yet. All right, so what will happen when, let me just add this other one, health checks up, oops, up, yeah. I'm alive and kicking. All right. What's the difference here? When your application returns a liveness with some error, like a 500, a 400, I don't know, the environment, the orchestration, for example, a Kubernetes, will kill that container. We are building this for running on containers. It will kill the container, it will kill the pod on the Kubernetes, and it will replace it, okay? It will create another one. But if the application is alive, but is not ready, the orchestration will wait, okay? Will just wait to be ready, all right? That's why I'm returning here, I'm not ready yet. All right, so if we go back to this guy here, now we have content, okay? So the application the status is up, okay? Because it's alive and it's ready. If I go here and mess with, for example, with the address of the other service and check again, okay, so it's down because it's alive, all right, but it's not still ready. And in this case, what the orchestrator will do, it's not sending requests to that service that's still not ready. So maybe you have some failover or another instance, I don't know, it will not send requests to that pod, to that container that's not healthy, right? That's why we call health check. All right, awesome. What we're gonna do right now is to add metrics to our service here, because in the cloud native context, we need to take care about observability, and health check is part of observability, but also metrics in order to monitor your application behavior. So let's move back to the code here. So I will close these guys just to save some space, and I will, guess what, add an extension. It will be metrics. Oops. Add extensions. Sorry. To this project. All right. So here, current project. Cool. Metrics. All right. Just finish. Okay. As in the same case that we got on the health check, here we have a free endpoint for metrics, 81 metrics. Oops. Oh, that's important. I know what's happening. Some extensions doesn't demand to redeploy, to restart the application, but some extensions demand. All right, so that's why we don't have the metrics still available here. So we just have a restart to our application, and it will be good to go. So really fast, 1.2 seconds to restart the application because of a new extension. All right, so here we have our metrics, and we have some groups. We have the base metrics. Oops, the base metrics. They are the metrics made that all implementations of microprofile needs to implement. We have the vendor metrics that are specific for each implementation, in this case Moraes from Red Hat, and we have our application that, guess what, I still didn't add any application method. That's what I'm gonna do right now. Good, let's go to the code. Here I will add, for example, let me make a little change just to have two places to add some metrics. I will have a public string get time, and I will, and here in this guy I will add a counted metric, right? So it will count, it will generate statistics related to how much time this method was called, the how much time for 5 minutes, 15 minutes, half an hour, 1 hour, and a lot of other stats related to it. And here we will add a timed metric. All right, so it's kind of counted but related to time, how much time this method takes to run. And here I will return the get time, so it is called. All right, so let me go here. Both of them are running. The last time that I've updated this application, it took 200 milliseconds to replace, to restart. So it's very, very fast. If you go above here, 174, and so Quarkus really take very few time to replace, to update your application. So let's go here to this application. All right, so here we have my metrics, the metrics that I'm generating with my application. If you go here, 125, 30, and 40, so a lot of metrics here. Here is the metric related to time, so 140 and so on. All right, so a lot of metrics here, both for counting and for timing. All right. So going to the end of this session, I will do two more things here. I will containerize our application, and I will deploy it to a managed environment, to a orchestrated, to a Kubernetes, right? So let's go back to our code, and here I will, let me stop these applications because I don't need them to be running anymore. Thank you. Thank you too. Thank you too as well, and thank you too. Good. Let me clean. Perfect. All right, so we are here in the gateway application, and I will add two extensions. I will add the container image zip, and I will add the Kubernetes extension. This will help me to be able to containerize this application and also to deploy it to a Kubernetes right from my terminal here. Okay, I don't need to pass through any other environment. Okay, right away I will be able to containerize and deploy this application on a Kubernetes. All right, and for doing this, I will need to add some configuration, some properties to my applications here. So this will be the only part that I will copy, because there are some properties and I don't want to miss any of them. All right, so I have here this, and just missing one Quarkus.Kubernetes service type. Yes. So what we are doing here, we are creating some properties for creating our container. So it will use Docker Hub on my account on Docker Hub, and this is the name of our application here, the version of the tag, and here is for Kubernetes. So it will create a load balancer service so we can access our application. And I told you that I would need to make some changes on this application, this second application. The first one, I don't need anymore to specify the port. Why? Because Kubernetes will take care of the port, so I don't have to take care of the port. All right? So this is the first one. And the other one is I want to use localhost anymore, just time, because my time application will get the host name of time when we are running on Kubernetes. And I will keep this port 8080 here because it's an internal port of the container. So again, Kubernetes will manage the access. So let's just go to the time application and do the same and add, let's add the extensions, right? So it will recognize them. So container image gib and Kubernetes. All right. And right now, this is the time application. Good, awesome, incredible. Let's go to the terminal, and here what we are gonna do right now. First, I will log in on my Docker Hub account, and I will finally package our application, and I will use Quarkus.Kubernetes.deploy equals true. I will copy this. This is for time. This is for gateway. While they do this, I will go to another window here and just access our cluster. Watch kubectl get pods, so we can see our applications being created on our yes. First one is being created, a time application, and now the gateway application. As we are using Quarkus, they go up and run really fast. Okay, so here you can see the application is alive but not ready yet. This is the health check. Okay, they should be creating some kind of an object inside the Kubernetes in order to be accessed. So let's just wait a little bit, few seconds, and it will be ready to go. All right, so it's ready to go. Then our application, we can check the service SVC. And it is important to say right now because probably it will not work still. Why? Because here we have a public DNS to access this application. Okay, we are running on AWS, and it's not unusual that it takes a few seconds in order to be available. So I will test, but probably won't be available yet. Sometimes even take some minutes, and I won't hold you here waiting. But just to you realize they are using the same internal port, but the external port, they are different, right? So let me try here. Not this one, it will be this one. So curl 8080 gateway. Oops, gateway. Yeah, as I guess it's not working yet. Let me just try to use a loop while we finish, and then we try back. And all right, so let's let our loop try to deliver. If we go back to the other windows here, let me check here. You can see that in the same time that we packaged our application, we also deployed it to the Kubernetes. So if we go here, deploy into Kubernetes server, and here's the address, here's the namespace, and apply the service, deployment, and so on. Here for the other applications, the same. If we look to the targets, alias target Kubernetes, we have here the Kubernetes file that were created for this application. So we can, for example, cat target Kubernetes. We can see the YAML. So this YAML file here, I didn't touch to this file, you saw. So it was always all created by the process of packaging our application here, right? So it's very helpful, it's very productive, right? Okay, let me just try again. If not, we finish. Yeah, it's done. It's available. So I can, for example, go to this DNS right here and put on my browser, and I have my browser accessing an application that I've just created in front of your eyes. All right, so I went to the Quarkus website, download the code, and coded it, and also published it on my public cluster. Awesome. So just to summarize here, that's what we just created on our cloud native application using plain Java, or Java with Quarkus, but using the microprofile implementation. All right. Okay, so thank you very much. I would like to end leaving this URL with you from Red Hat developers. I told you I'm a developer advocate, and I'm working here at Red Hat with Red Hat developers. At this site, you can scan using QR code or going to this URL. You can access a lot of content, all free content, right? As all that we do here at Red Hat related to content, all of our contents are free, and this is the case for Red Hat developers. So check it out. You can subscribe, and we will send you monthly or kind of monthly some content related to Java, Kubernetes, Cloud Native, OpenShift, Kubernetes, Istio, Knative, Tecton, and a lot of good stuff and fun stuff. All right. So thank you very much. I'm available to you if you would like more help. If you have some questions, don't forget to send me a message. You can use my Twitter. My DMs are open, and I'm always available to help you. See you next time. Bye-bye.